All right, so we're going to figure out our favorite trig function, and our favorite trig function is going to be sine. Now, it seems maybe backwards because that's the y. Why wouldn't we do the x? That comes first. That's what my wife said. Hers is cosine. Opposites attract. Sine is going to be our favorite trig function. Okay, sine is going to be our favorite trig function because every other trig function can be gotten from sine. Okay, cosine is the co-function, in other words, complementary angles, and we'll learn all that. Tangent we can get if we know sine and cosine, but again, if we know sine, we can get cosine. Okay, so sine is going to be our favorite trig. All right, so with that said, I'm looking just at the y coordinates. Okay, so I'm looking at 0, I'm looking at this, I'm looking at that, I'm looking at that, I'm looking at that here in the first one. Okay, here's a trick. Put your hand on, you see it already? Yeah. Right? Okay, so you see the x-axis here, the y-axis here, and then those three, right? 30, 45, and 60. Got it? Okay. Here. Okay. Get that marker and trace around my hand. Now, you know what's funny about this is the person, Seth's watching this in the video, he can't see this. Right now, Seth, Caleb is tracing around my hand. It's on the board. You can't see it, but okay. But you know what I can do is, okay, Seth, now you can see this. Here's what we do. That's a fat finger. All right, so there we go. So, just looking at the y coordinate now, because sine is our favorite trig function, and sine is the y. Okay, look at the pattern. Just the y coordinate now. Square root of 0 over 2. Square root of 1 over 2. Square root of 2 over 2. Square root of 3 over 2. And square root of 4 over 2. Isn't that true? Yep. This would be 0. This would be 0. 1/2. Square root of 1 is 1. Square root of 2 over 2. Square root of 3 over 2. And square root of 4 is 2. 2 over 2 is 1. Okay? And the cosine then actually goes backwards. Right? But I think if you can get the y's, you can get because this is 45, and so the x and y are the same because it's an isosceles triangle. So this is going to be 45, 45, so it's going to be square root of 2 over 2 and square root of 2 over 2. And then these are just reversed. So if you get this one's 1/2, you know that's root 3 over 2. If this is root 3 over 2, that one's 1/2. Okay, so but it's true. Cosine goes backwards. So that's what I'm saying. If cosine's your favorite trig function, then do the same thing, but just go in reverse. Start up here and go down. Okay? I don't know. Maybe. If that's helpful to you, do. Okay? That's helpful. Okay, so starting here, square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 3. Once you have those, the rest of them come easy, right? Because what's different over here? What's different in quadrant 2? The x is negative. In this quadrant, x is negative because you got to go this way, and then the y is positive. So this point's going to be the same, right? It's going to have the same x except negative, and the y's are definitely the same. Here the y's are the same, here the y's are the same because they're the same height. So the y's are the same in the first and second quadrants. Okay, but the x's are just opposites. When you get down here, they're both negative. Okay, so these two are going to have the same x right here. They're both going to have x come over to here. They just have opposite y. This one has the same x as this one. This one has the same x as this one. Okay, so they're both negative. Both coordinates are negative here, and then the x's are positive. So so these two are going to have the same coordinate. They have the same x value, but this one goes down instead of up. So if you get those in the first quadrant, the rest come easy. Okay. All right. So, just a thought. Something you can try if that's helpful. Now, we're also going to talk probably tomorrow, we'll see if we get time later today, about right triangles, about what you learned in geometry with right triangle trig and SOHCAHTOA and stuff like that. And you can come up with them that way too. We can put triangles in here, and you can do it that way. Okay? And so maybe that makes sense too, but I think this might be a little quicker. If you work with them a little more, you'll get the hang. Okay? All right. So there's that. So we want to be able to do this. So for right now, you can still look at your sheet. Now on our quiz, we'll do a quiz with no calculator where you will have to, you'll have to know. Okay? And so over this week, we want to be thinking about memorizing. So we're going to do some problems here very shortly. I'm going to throw some up and let you try them. And if you have to look at your paper, fine. But we'll try to wean yourself off of having to look at that. Okay, now, another thing let me go to it right here. Another thing I've done, and maybe you could write these on your unit circle now if you want to. I've just put the decimal version of those. Okay, now maybe just in the first quadrant. Maybe just in the first quadrant if you want to write those. In other words, remember this point was 1/2 and square root of 3 over 2. And this was square root of 2 over 2 and square root of 2 over 2. And this was square root of 3 over 2 and 1/2. So I just put the decimal equivalent of those. Now, because eventually we'll be using our calculators a little bit, and if you know those decimal equivalents, you can, you'll recognize that. You say 0.866, oh, that's square root of 3 over 2. 0.707, oh, that's square root of 2 over 2. So it's not a bad idea to just kind of know those or be familiar with those. It's probably not a huge deal, but it can be nice to know. Just like the other decimals we said was important to know, like pi halves is 1.57 and pi is 3.14 and 2 pi is 6.28. And this one down here is 4.71. If you take 3 pi and divide it by 2, it's 4.71. So those are nice decimal numbers to know. 3.14, 6.28 are easy, but then these sometimes. So those are some decimals. All right. So anyway, let's take a look at the homework. So you've got your unit circle potentially in front of you. So let's talk about this. So what we didn't get a chance to talk about on Friday very much was tangent. Okay. So what do you have for 17? And I'm going through this in a little more detail maybe than I might normally. If you thought this was really easy, great. But I think this is so important for the future that we have this down. I think it might be worth slowing down just a little bit and spending some time here. So what do you got for pi halves? So what's the sign? So here's our unit circle. What are we looking at pi halves for sign? What do you got? 17. You're supposed to do sine, cosine, and tangent. Right?
Sine is
What do you got?
root 2 over 2.
No.
Oh, it's not the right.
Did I write it down wrong?
It's pi over.
You guys all. I thought. All right. No wonder. Like that? What'd you get for root 2 over 2? And for tangent? Okay, what we haven't talked a lot about is we said the tangent is y over x. Now, we'll get used to what those numbers are too, and we'll talk about that here some today. Okay, tangent is y over x. The other thing we haven't talked a lot about, I put them up here the other day, are these other trig functions, cosecant, secant, and cotangent. They are reciprocals of these. Okay, and so and again, another reason I wanted to slow down just a little bit here, because I threw a lot at you on Friday, and it was Friday, and now we've got a 3-day weekend, so and we've just kind of taken a quiz and all those things. So sine, so this was something we had yesterday, or last week, and I've added to it here. So cosecant, and I don't know that you remember 1 over y. I think what you remember is cosecant and sine are kind of paired together. Cosecant and sine are kind of paired together. They're reciprocals. right? Their values are reciprocals. And so what that means is if sine is the y, then cosecant is 1 over the y. It's the reciprocal. Cosine goes with secant. Now it seems kind of weird. It seems to be nice if sine and secant went together, but they don't. Cosine and secant are reciprocals. Now, cotangent obviously goes with tangent, so that one's a little easier to remember. Tangent, cotangent are reciprocal. Okay? All right, so back to this. So tangent is the y over the x. Oftentimes we say this is a rule we will actually have later on because it makes sense that this is true. Tangent is sine divided by cosine. That's what we're just saying. It's y over x. Y is a sine, x is a cosine, so definitely that would be the same, sine over cosine. So it's just this divided by this, which is 1. Okay, pi thirds. What's the sine? And I purposely put these in different order. Why? Well, to make you think as we do this. But number 2, sine's my favorite period. Okay, pi thirds is up here. Sine is the y, so it's root 3 over 2. 1/2. Now what is tangent? What do you have for tangent? It's sine or the y over x. Now what's going to happen here? You're going to flip this up, right? And those are going to cancel. Bottom line is you have a fraction over a fraction, you can cancel the bottoms. Okay, you can cancel the bottoms. So those two basically cancel. But it's because you flip it up. So it's going to be just root 3. Root 3. Okay? So just know when we take this over this, the 2's are going to cancel. Because every one of them has a 2 on the bottom, right? So we're going to have it. We're going to have a 2. All right. And then negative pi 6. Well, now you got to know that that goes down here. Negative pi 6 goes down here. Okay? So what's a sign? Negative 1/2. Positive root 3 over 2. And then what do we got here? How do we want to write this? It's going to be negative 1/2. It's y divided by x. So it's going to be negative 1/2 divided by root 3 over 2. Invert and multiply. Right? Or just say those cancel, however you want to do it. That's going to be negative 1 over root 3. We don't want to leave it like that. So what are we going to do? Multiply by root 3? So it's going to be negative root 3 over 3. Root 9 would be 3. So it's negative root 3 over 3. So we're going to put negative root 3 over 3. So now, so let's talk about tangent here a minute. We've just seen the 3 different things that tangent can be. Now tangent can also be 0, it could be undefined. We'll get to that in a minute. Okay? But when so it just depends. I mean, look at the different x's and y's you have. It's y over x. So if you have root 3 over 2 over 1/2, the root 3 is on top. That's going to be root 3 over 1. That's going to be root 3. If it's the other way, if it's the 1/2 over the root 3 over 2, 2's cancel, you get 1 over root 3. Just know 1 over root 3 is going to be root 3 over 3. 1 over root 3. I'm not going to do this every single time, right? When I see 1 over root 3, I'm just going to know that's root 3 over 3. Okay? Because of that algebra right there. Root 3 over 3. Okay? So it's either going to be root 3 over 1 or it's going to be 1 over root 3, which simplifies to root 3 over 3. Or it's going to be a 45-degree angle and you're going to have root 2 over 2 over root 2 over 2, which is always going to be 1. It could be negative 1 if one of them is negative. So at the 45s, tangent will always be 1 because the y and x are the same. You take y divided by x and they're the same, you're going to be 1. Okay? So those are really the only options for tangent. So tangent's not really on our circle anywhere, but when we divide y divided by x, we know we'll always get one of those 3 right there. Or an undefined. Yes?
Root 6 over 2 is not the same thing as root 3, right?
No. Root 6 over root 2 would be the same as root 3. But now where are you getting 6 and 2?
When just on the flip multiply on 18.
On this one?
Yeah, I just didn't do the root 3 over root 3.
Hang on. I want to catch any of these algebra mistakes here. So tell me that again. So on 18,
yeah,
it'd be 1/2 over root 3 over 2.
Yeah.
And what'd you do?
So you flip it, so 2 over.
Oh. And then you just multiply across?
Yeah.
Or did you cancel the twos?
I got root of 6.
I don't know where you got a root of 6. You can't get root of 6 here unless this was, unless you did the top and bottom by root 3 here. But even that wouldn't be root 6.
Yeah.
That would be 2 root 3 over, and then this would be root 9, which is 3. 3 times 2 is 6. So you get 2 root 3 over 6. And that would, I don't know. I don't know. You would never get a root 6 in it. Yeah. Because to do that, you'd have to have a root 2 times a root 3. And I guess unless you used one of these 45 ones, but I don't know. Yeah. You should never get a root 6. Any way, shape, or form. Okay, negative pi fourths would be down here, right? So the sign would be negative root 2 over 2, because the y is negative down here in quadrant 4. The x is positive, so that'd be root 2 over 2. So hopefully, so you start, we're going to have something here in a few days called a reference angle, okay? When you're down here in quadrant 4, that's actually 7 pi fourths, or negative pi fourths, but really the angle you're thinking of is pi fourths. You're really thinking of these numbers here. You're just thinking, but the x would be positive and the y would be negative. So the sine is negative and the cosine is positive. And then if you put y on top of x, sine on top of cosine, you get negative. Okay? All right, 21. Negative 7 pi fourths. What quadrant is negative 7 pi fourths in? Quadrant 1. Okay? Now, maybe that's the first thing we should talk about, or go back and review, is get them in the right quadrant. Because, if you get this memorized, if you know what these coordinates are, then it's just a matter of getting in the right spot. And then you got it. So negative 7 pi fourths. Now, there's a couple ways to do this. What I would do, I think, is I would just go around. Remember the counting thing I did the other day, right? When I see 7 pi fourths, I think 1 pi fourth, 2 pi fourth, 3 pi fourths, 4 pi fourths, like that. So negative 1 pi fourth, negative 2 pi fourths, negative 3 pi fourths, negative 4 pi fourths, which is negative pi, negative 5 pi fourths, negative 6 pi fourths, negative 7 pi fourths, right there. Okay? Now what you could do is just add 2 pi. Remember we did coterminal? Coterminal, you just add 360, right? Well, you can do the same thing here. You could add 2 pi. So you could take negative 7 pi fourths and add 2 pi. Now that'd be 8 pi fourths. So take negative 7 pi fourths and add 8 pi fourths, you get 1 pi fourth. And those should be in the same spot. Remember, that's what coterminal meant. Angles that are in the same spot. So take negative 7 pi fourths, add 8 pi fourths, 2 pi, you get 1 pi fourth. So these should be in quadrant 1, pi fourths. So that's just going to be root 2 over 2, root 2 over 2, and 1. Okay, negative 4 pi thirds. Well, again, what quadrant? Well, here would be negative 1 pi third. Remember, that's 60. Pi thirds, 180 divided by 3 is 60. Negative 1 pi third, negative 2 pi third, negative 3 pi thirds, which is negative pi, negative 4 pi thirds would be right up here. Okay, or add 2 pi onto them. Add 6 pi thirds on the negative 4 pi thirds. That'd be 2 pi thirds. That's right here in this quadrant. 2 pi thirds is the equivalent. So sine would be root 3 over 2. Cosine is negative 1/2. I'm just taking the y and then the x. And now what's tangent going to be? It's y over x, right? Sine over cosine. So the 2's will cancel. Is it going to be negative root 3? Because it's going to be root 3 over negative 1. Because the 2's will cancel. Again, I don't want to write that every time. It's root 3 over 2. You can until you get the hang of it. It's going to be that. Invert and multiply. Cancel, cancel. You get negative root 3 over 1. Okay? 11 pi 6. Well, that's on here. Right? That's right here. That's down here in quadrant 1. So sine would be negative 1/2. Cosine's root 3 over 2. And then what's tangent? It's y over x. What's negative 1/2 over root 3 over 2 going to be? The 2's will cancel. It's going to be negative 1 over root 3. But what is that? That's going to be negative root 3 over 3. Right? Because of the algebra we did earlier. So it's going to be negative 1 over root 3, which would be negative root 3 over 3. Okay, 5 pi thirds. Again, that one's on here. 5 pi thirds is down here. No, 5 pi thirds is over here. It's in quadrant 4. Right? 6 pi thirds would be 2 pi, so it's almost all the way over there. It's pi thirds short of that. So 5 pi thirds right here. So sine is negative root 3 over 2. The cosine is 1/2, which is the x. And then tangent is the y over the x. Negative root 3 over 1. Negative root 3. Right? Negative root 3 over 1. The 2's would cancel. Okay? All right, last two. Negative 3 pi halves. Where's that at? What angle is that the same as? Let's put it that way, because it's not in a quadrant. It's the same as pi halves, right? It's the same as pi halves. If you add 2 pi to that, if you add 4 pi halves, that give you 1 pi half. But it's 1 pi half, 2 pi halves, 3 pi halves in the negative direction. It's right there. 0, 1. So the sine would be 1, the cosine would be 0, and the tangent would be undefined. And that's why in the directions they say find the value if possible, or if it exists, or I don't remember what it said, but something like that. Okay, and evaluate if possible. So it's undefined. Okay, negative 2 pi. Well, where's negative 2 pi? That would be all the way back around to here. It would be the same as 2 pi. It'd be the same as 0. So it's this point right here. So the sine is 0, the cosine is 1, and the tangent is 0. It's fine to have 0 on top of a fraction. You just can't have 0 on the bottom. So 0 divided by 1 is 0. So the tangent is 0. So tangent, again, depends on sine and cosine. It's the y over the x. It's a sine divided by the cosine. All right. And then the other 3 are just reciprocals. I didn't ask, you didn't have any of those. So we can get all 6 trig functions just by knowing sine and cosine. Just by knowing those x and y coordinates on the unit circle, we can get all the rest of them. Because they all have to do with the x. Okay, and if you know the reciprocal partners, you're in business. All right. So, you guys try those right there. See if you can do it without looking at your sheet. And if you have to, yeah. It's all right. Pencils stop moving. Give it up. Cosine 3 pi fourths. What quadrant? Where's 3 pi fourths? Quadrant 2. 1 pi fourth, 2 pi fourths, 3 pi fourths. I'm thinking of 3 pi fourths here. Oh, that's an easy one. That's that 45-degree one. I know these have to be the same. That's got to be root 2 over 2 because that's the one that's the same. And I know in this quadrant the x is negative and the y is positive. So it's got to be that, right? So cosine would be the x, negative root 2 over 2, right? And eventually all that thinking is in your head, right? 3 pi fourths, that's over here. X would be negative, y would be positive. It's a 45-degree situation because of the pi fourths. Root 2 over 2 comes to mind. 3 pi halves. Down here. Oh, that's an easy point to remember, right? That's got to be that. What's tangent? Y over x. Sine over cosine. Negative 1 over 0. What is that? Undefined. Tangent of 3 pi halves is undefined. 11 pi 6. Where's that at? Right here. 11 pi 6 would be 1 pi 6 short of 12 pi 6. 12 pi 6 is 2 pi. So it's 1 pi 6 short of that, which would be this last spot. Well, I know if I remember, I'm thinking of my hand now, thinking of my y, square root of 0, square root of 1 over 2. So this one is 1/2. Same thing going down. It's got to be negative because it's down here in the y. And then I know if that's 1/2, then this is the other one. This is that root 3 over 2, right? So thinking of my hand, square root of 0 over 2, square root of 1 over 2, square root of 2. Okay, so this point matches with that point. So it looks like it would be that. So the sine, cosecant, what's that one pair with? What's cosecant pair with? The y, sine. Cosecant pairs with sine. They're reciprocals, right? So we look at the sine, the y, we do the reciprocal. Okay. What about 19 pi over 6? Where is that one at? What quadrant is that in? Which one? That is in 3. Now, you can count and go around, or you could just, remember we talked about coterminal, add or subtract 360, or add or subtract 2 pi. So to me, when I get a big one like that, I think about 2 pi would be 12 pi 6. So if I take off 12 pi 6, this would be the same as 7 pi 6. Okay? Now I could count all the way around. 12 pi 6, 13 pi 6, 14, 15, 16, 17, 18, 19 right there. But that's 7 pi 6 right there. This would be 6 pi 6. So 1 pi 6 after that. Well, what do I got? I know that this is going to match up with this point, right? And this one. So this was the one I already, and this one here. So this is going to be root 3 over 2. Right, and 1/2, but they're both going to be negative. So this point always matches with that, with that. Those coordinates are the same. They all have the same x, right? They're the x that goes almost all the way out to the end of the circle, right? So that x has got to be the same as that x. They got the same y. They got the short y segment, right? Except one's positive, one's negative. All right, so we got that. And what do we want? The tangent. So we want y over x. What would that be? What do you get if you take negative 1/2 over negative root 3 over 2? 2's cancel. 1 over root 3, how do we write that? This would be root 3 over 3. Positive, because they're both negative, so we divide, right? We flip that. You could flip it up if you want. If you want to show that work every time, not a problem, right? You want to flip that up. Negatives cancel. 1 over root 3, multiply top and bottom by root 3, you get root 3 over 3. Okay, there you go. Okay, all right. Try those. Now notice I put those parentheses in there. A lot of times the book doesn't do it. I don't like it. It's a function. It's like f of x. It's like who would ever write a function fx like this? You never would. You would always put parentheses around that. But a lot of times the book doesn't. So, but understand that means sine of pi 4s. Okay, I know that may not be enough time for all of them, but what do you got for sine pi fourths? And you can just make these up all day long, right? I mean, you can just make these up all day long in practice. But anyway, sine pi fourths, what do you got? Quick, shout it out. Root 2 over 2. What about number 2? Cosine 5 pi 6. Root 3 over 2, negative or positive? Negative. I just had to fix mine. I had negative 1/2. I admit it. I was thinking sine. All right. Well, sine wouldn't even be negative. I don't know what I was thinking. Tangent of pi. 0. Sine of negative 2 pi thirds. Negative root 3 over 2, because that would be down in the third quadrant. Negative root 3 over 2. Cosine pi. Negative 1. Cotangent 0. Isn't that one undefined? Because cotangent would be the reciprocal of tangent, so it's going to be x over y. 1 over 0. Undefined. Okay? All right. So that's what I had there. So I missed one. I got 5 out of 6. All right. So, make a quick note. We're going to divide the homework up into a couple parts. We're going to have some work time here. We don't have a lot of time for lunch. Let me just talk about number 6. You have a couple problems that are just like that. Then 27 through 33. It's not very many problems. We'll work on it a little bit before lunch here. But here's what number 6 looks like. They give you an angle and they give you a point on that circle. This is a unit circle now, okay? And they give you this point right here, okay? And they want you to write all of the 6 trig functions, okay? So it's basically what we've been doing, except it's not one of our special angles. It's not pi thirds or pi fourths or pi 6. Who knows what it is? It's just some point. I mean, those are only the special ones are just a handful of special points on the circle. There's a lot of points on the circle, right? Here's one of them. What would be the sine of this angle? What would be the sine of theta here? 15 over 17. It's the y, right? Easy, yes. What's the cosine? Negative 8 over 17. Yes. What's the tangent? Negative 15 over 8. Now we usually put the negative on top, but 15 over negative 8, yeah. Put the negative on top. I don't care about reducing it, mixed numbers, whatever, just because the 17s would cancel. Remember, it's y over x. It'll be the sine over the cosine for tangent. What's a secant? That's a reciprocal of which one? Secant's a reciprocal of cosine, so it's going to be negative 17 over 8. Cosecant. 17 over 15, it's a reciprocal of sine. What's cotangent? Easy, easy, right? But everything revolves around those 2 points. If you know the x and the y, you know the sine and the cosine, you get tangent, you get the reciprocals, you get everything else. All right, first part of our homework. Now, this is actually going to change. I think there's going to be more to it than that. So right now, just do this part right here. Okay, we'll work on that till lunch, and then when you come back, just start working on it. I'll give you 5 minutes or so. We'll work on it, then we'll finish up the rest of what we're going to talk about today. So yeah, don't pay attention to that. Go ahead and finish up with what we need to talk about, and then you can go back to that if you're not done with those, and then we'll add a few more problems to it, and then you can work the rest of the time. Okay? So, unfreeze this, I guess. All right, so bottom line is we've got the unit circle, we've got these coordinates. With that, we can find what we call our special angles, right? Pi 6, pi thirds, pi fourths, pi halves. You know, the 30, the 45, the 60 degree, the 90, those angles are special angles. we want to memorize those. We want to know, if you look at the calculus, the AP calculus syllabus, one of the prerequisites it talks about, one of the things that they want to make sure students know are those trig values for those angles and multiples of those angles, so rounding in a circle, okay? So we will continue to work on that, but I think we went a long way towards getting that today, hopefully. All right, so let's talk about sine and cosine as functions, okay? Let's talk about them, and when we started in chapter 1, we talked about domain and range and stuff like that. So let's talk about these as functions, that we plug something in, an input, which is an angle, right? Well, now actually, I don't have to call it an angle, but I think it's good to think of it, the input, as an angle. It's pi 6, it's these kind of things. It's in radians, it could be in degrees. Go ahead and get your calculators out too right now if you don't have those out. We're going to show you how we can do that with these as well. But the idea is the input is an angle. Now, since we're using radian measure though, remember in the unit circle the angle is the same as the arc length. So a radian is really an arc length. But we can think of it as an angle as well. But it doesn't have to be this rotation. So in a sense, the input is just any real number, okay? Now, where that becomes advantageous, as you'll see later on, is we can use the sine curve. We can do a graph of the sine function to represent the annual or the average daily temperature throughout the course of a year, or the sales of seasonal equipment like snow skis. They're up here one, and then they're low probably in the summer, and then they're back up here in the winter. That's kind of what the sine and cosine functions are used for. Okay, so they're not all about triangles and degree measures. They're actual number inputs. And that's where radian measure is a big advantage, okay? And that's why we use it. So anyway, we have inputs and we have outputs. So the domain of the sine and cosine functions, all reals. We can plug anything into the sine and cosine function. Now, obviously not tangent. We already saw sometimes when tangent was undefined, right? Whenever cosine is 0, whenever the cosine value is 0, tangent's going to be undefined because it's sine divided by cosine. It's y divided by x, okay? So whenever cosine has a 0 output, tangent is going to be undefined. So tangent's a different story, but we're not going to mess with that right now. For sine and cosine, the domain is all reals. We can put anything into them, okay, and get out an answer. The range, well, you tell me. Think of the unit circle, and let's just take cosine. Cosine is the x-coordinate. What's the smallest? Look at the unit circle now. The unit circle, right? The unit circle, the x-coordinate on the unit circle is cosine. What's the littlest cosine can be? What's the littlest? Look at your unit circle. What's the littlest that the x-coordinate can be on the unit circle? -1. What's the biggest x can be, the x-coordinate? +1. So cosine, the littlest and the biggest the cosine can be is -1 to 1. What about sine? Sine is the y. What's the littlest sine can be? -1. What's the biggest? Sine and cosine, the range of both is from -1 to 1. You will always get out a number -1 to 1. Now let's do something with our calculators really quick. So this is something we want to memorize. Domain, all reals. We can plug anything into the sine and cosine functions, any angle we want. -infinity to infinity. But we will always get out a number somewhere between -1 and 1. Like √2/2 is 0.707. √3/2 is 0.866, right? We always will get cosine or sine will give out values between -1 and 1. All right, on your calculator, let's do sine 30. Type in sine, hit your sine button, and then 30 and hit enter. What do you get? Are you getting 0.5? Now think about that, shouldn't we? Sine of pi 6, think about pi 6, right? Think about pi 6 right here. The y, square root of 0 over 2, square root of 1 over 2, 1/2, right? Square root of, so we should get 1/2. Sine of pi 6, sine of 30 degrees. But now let's do sine of pi 6. So type sine, and then does a parenthesis come up when you hit sine? Now hit the pi button, divide by 6, close the parenthesis, hit equals. What do you get? You get 1/2? You don't get 1/2. Why not? See on your calculator how it says DEG? Doesn't it say DEG right now? Depends on your calculator. You're in degree mode. You need to be in radian mode. So find your DRG button. I think most people have a DRG button. You find it? Now does it say rad on there? Okay, now you're in radian mode. Now do sine of 30. Now do sine of 30. What do you get? You don't get 0.5 anymore, do you? Because you're not doing sine of 30 degrees. Now you can override it. Most calculators have a degree symbol where you could type sine 30 and then the degree symbol, and that'll override the rad mode, but don't worry about that right now. So, are you still in rad mode? Now do sine of pi 6. Sine, left parenthesis, pi divided by 6, right parenthesis, hit equals. 0.5? Yeah, you get 0.5. So you gotta depend, so it depends which mode you're in. So you gotta be careful then. Okay? So we'll be doing some, and I think on your homework there's a few where you're just supposed to type them into your calculator. Now what happens if you got a cosecant? What if you want to do the cosecant? Go back to degree mode. What if you want to do the cosecant of 30 degrees? What would you type in? Well, no, not second. It's not second. You would think it would be, because if you look at the sign, it's got sine -1, and that -1 is supposed to be reciprocal, but it doesn't. It means inverse function, and that's a whole different thing. So we don't want to hit second sign. That's a special thing that we will do, and it's really confusing, and it's too bad to use that notation. But we're going to do sine of 30 and hit equals. We're going to do sine of 30 and hit equals. Back in degree mode now, right? Did you get 0.5? Now, do you have a 1 over x key or a x to the -1 key? That's your reciprocal key. Hit that. And then it should give you 2. So we do that at the end. So what we do is if we get a cosecant, a secant, or a cotangent, and we want to do it on our calculator, we do the sine, cosine, or tangent first. We get that value, and then we hit the reciprocal key. And then that'll flip. Okay, so we'll do that if we're getting into decimals. Now, we wouldn't do that with 30 because we're supposed to memorize that. But maybe we have 42 degrees or 76 degrees or something. And then maybe we want to do that on our calculator. Okay, so you'll have a few like that to do in your calculator. All right, let's keep going with our discussion of sine and cosine as a function. Okay, so sine and cosine are periodic functions. Periodic functions. Have you ever heard this term? With functions. Ever? Okay. Periodic functions. A periodic function is a function that repeats. A function that repeats. Now, it's more specific than that. Okay? A periodic function is any function where f of x plus p is equal to f of x for all x and some period p. Period is the length of the repeating. So what that means is if I put in a 2, I get a certain output. And if I add on one period, like let's say the period's 5. So I put in a 2 for x, and I get out some value. I do 2 plus 5, and I put that in, like 7, and I get out that same value. They'll be equal values. They will equal each other. The outputs will equal each other. And then if I add 5 again, I put in a 12, I get out that same output over and over again. So every 5 units, I go up by 5 or go down by 5 on what I put in, I always get out the same thing. It repeats its y values over and over and over again. That's called a periodic function. Well, what is going to be the period of sine and cosine? It's going to repeat its values every what? And let's do radians. Every how many units? Do radians now. Think coterminal. Here's a point on the unit circle. Say that's pi thirds. When's it going to get back to that point? 2 pi. 2 pi. Remember we said add or subtract 2 pi. If you add or subtract 2 pi, you get the same thing. You get the same exact thing, the same point in your circle, because you just go back around and you go around and you go around and you can subtract, you can go negative, right? So the period of the sine and cosine function is 2 pi. Okay, the period for the sine and cosine function is 2 pi. Okay, because that's just another time around the circle. Now, on your homework, you're going to get, we've already talked about it today. On your homework, there's going to be some questions that say, use the fact that the period is 2 pi to do these problems. So, for example, they might give you sine of 20 pi 6. Now, there's no way, 25 pi 6, there's no way for you to actually show this to me. Well, there is, but I'm not going to make you do it. But let's say the problem is sine of 25 pi 6. And they're saying, use the period, use the fact that it's a periodic function to find this. Well, what you do is you say, okay, 25 6, where's that going to be? What quadrant? Remember we did this before lunch? What quadrant? Well, what's 2 pi if your denominator is 6? 12 pi 6? So we can take off 12 pi 6. What would you get? 13 pi 6. Oh, we can do it again. Take off another 12 pi 6. You get 1 pi 6. Oh yeah, what's sine of 1 pi 6? What is it? 1/2. So what are these? All 1/2. Because these are going to be, this is going to be pi 6, and that'll be 13 pi 6, and that'll be 25 pi 6. You keep adding on 2 pi, you keep adding on 12 pi 6, you just get back to that same spot over and over again, and the y value at this point is always going to be 1/2. The y value at that point is always going to be 1/2. Okay? So that's why you see the domain is all reals. We can plug in any number, we keep going forever. We can go to the negative. But every 2 pi, it's going to repeat that same output over and over again. So, cosine of 5 pi 6. Where's 5 pi 6? What quadrant? 5 pi 6, what quadrant? Quadrant 2. And at this point right here, 5 pi 6, right? There's 5 pi 6 right there. What is the cosine there? What's the x-coordinate right there? Negative, not 3/2, but root 3 over 2. It's going to be negative root 3 over 2 right there, right? Good, some of us are getting it. Negative root 3 over 2 is going to be that x-coordinate. That's cosine, negative root 3 over 2. So what would be another one that would have negative root 3 over 2? Now, I know there's another one down here. I know this one would also have negative root 3 over 2, but that's not what I'm saying. I'm saying that repeats. So go around another 2 pi. So what would you add on if it's pi 6? 12 pi 6. So what would be one? So 17 pi 6. You know what? Let's go the other way. Let's take away 12 pi 6. What would it be? Negative 7 pi 6, right? And that would also be negative root 3 over 2. Negative 7 pi 6 would also get you to this point right here. So every 2 pi, you just go around the circle, and you end up at the same point, and they're going to get the same outputs. That's a periodic function. Periodic function. Okay, sine and cosine are those. All right, last thing. Even odd functions. Remember this? Even odd function. We talked about symmetry. Now, you're going to have to get comfortable with this function notation. Some of you, we spent a lot of time with symmetry doing the negative x, negative y thing, and that's okay. But we really got to get more comfortable with this function idea. Now, here's what we said with odd functions. That if you put in opposite inputs, you get opposite, outputs. So that means, so sine, cosecant, tangent, cotangent are all odd functions. So those 4 are odd functions. Okay? Now, the fact that we know they're odd functions, we know this. Okay? Now think of it this way. If I put in t, if I put in pi 6, let's say I'm here, right? And here's my radian, here's t. What's negative t? Well, negative t would be down here. Well, what can you tell me? But now remember, sine's the y. Sine's the y. What can you tell me about the y coordinate here compared to the y coordinate here? They're opposites, right? They're opposites, so that makes sense. So sine of pi 6 we know is 1/2. Sine of negative pi 6 is negative 1/2, right? So now, big deal. Well, I could have figured that out anyway. I could have just thought negative pi 6. That's true. But if you know it's an odd function, it's even quicker. Sine of negative pi 6, you can say to yourself, oh, it's an odd function, so that's going to be the opposite of sine of pi 6. I don't know that you have to do that. I'm just saying that's something that's a fact. On your homework, they're going to ask you, have some questions with these negatives and see if you can come up with that. Okay, cosine and secant are even functions. Again, remember those were partners, cosine and secant. So they are even functions. Why is that? Well, think about cosine. Think about this same example right here. Put in a t or put in a negative t. If you put in opposites, t and negative t, what do you know about cosine? Cosine's the x-coordinate, remember? Okay? What do you know about the x-coordinate of this point and the x-coordinate of this point? Aren't they the same? The x-coordinate of this point is the same as the x-coordinate of that point. They are the same. So you put in opposites, you get out equal outputs. So cosine, and so my example I'm giving here, so cosine of pi 6 is root 3 over 2. Cosine of negative pi 6 is also root 3 over 2. Because they're even functions. You put in opposites, you get out the same. So if I got a cosine negative pi 6, I'm like, hey, cosine's an even function. So putting in a negative pi 6 is the same as putting in a positive pi 6. Okay? This can be useful, but at the end of the day, you don't have to do that. The directions will say use odd even functions to do these, but to be honest, cosine negative pi 6, you just know it's down here. What's that point? You can get it that way. Okay, so I'm not really adding a new way to do any of these things that you have to do. I'm just adding another one, another fact about these functions that's based on something we've studied, even odd functions. Later, we're going to look at the graphs of the sine and cosine functions. Just like the parabola function is or your quadratic function is a parabola, sine and cosine functions have a picture, a graph. We're going to look at those, and we'll see the symmetry, and we'll be able to understand this even better from that standpoint. Okay, so there's more to come on that. All right, so that's a little bit these additional problems. So these will just add on to the ones you already did. Okay, so just a few more there. This last batch is just type into your calculator. Okay, I think if you look, they're all in radian. If you don't see a little degree symbol, then it's radian. So if they say do the sine of 6, what quadrant would that 6 be in? If they say do the sine of 6, that's in the 4th quadrant, right? Because 6.28 would be almost all the way around, right? So that would be quadrant 4. Now what would be sine of 6 degrees? What quadrant's that in? That's quadrant 1, right? So sine of 6 degrees is different than sine of 6. So if there's no degree symbol, we assume it's radian. Make sure your calculator's in the right mode. Okay? All right.